this is actually section 7.4. Homework was 440 to 441, number 48 to 70, every other even, and I'm going to do 47 to 71, every other odd. So here we go. All right, now that we've learned how to add and subtract radicals and multiply and divide radicals, we're going to combine everything and we're going to do all different operations in dealing with radicals. So remember, just a quick reminder, when you are multiplying and dividing radicals, you are going to make sure the index is the same. And when you are adding and subtracting radicals, you're going to make sure that the index and the radicand are the same. And if so, then you can add and subtract. Okay, so here we go. So the first thing we're going to do with this problem is we're going to distribute. We're going to distribute the square root of 7 to both the square root of 5 and the square root of 3. So when we're distributing, we're multiplying. So we're starting with the square root of 7 times the square root of 5. The reason that you know you can multiply these together is because they both have an index of 2. So the square root of 7 times the square root of 5, you just multiply the radicands together, and you get the square root of 35 plus, and now we're going to take the square root of 7 and multiply it by the square root of 3. We can do so because both of our indexes are the same. You just multiply the radicands, and so 7 times 3 is the square root of 21. You cannot take that any further because your radicands are not the same and they can't be simplified anymore. So your answer is just the square root of 35 plus the square root of 21. All right, same situation here. We're going to distribute the square root of 3x to both pieces, both the square root of 3 and the negative square root of x. So first thing you need to do when you are multiplying is make sure that your indexes are the same. So you've got the square root of 3x and the square root of 3, and that's going to become the square root of, multiply your radicands. So 3x times 3 is the square root of 9x. And then you're going to take the square root of 3x and multiply it times the square root of x. You can do so because your indexes are the same. And you're going to end up with negative the square root of your radicands multiplied together. So 3x times x. And that gives you 3x squared. Okay? So now we can't subtract here because though our indexes are the same, our radicands are different. So let's see if we can simplify these any further to see if we can subtract. We know the square root of 9 because we can break this into the square root of 9 times the square root of x, right? The square root of 9 is 3. And we can't do anything with the square root of x, so we'll just leave it the square root of x. Minus, you can break this down into the square root of 3 times the square root of x squared. Can't do anything with the square root of 3, so we'll leave that down here. But the square root of x squared, remember your square root and your square cancel each other out, leaving you always the absolute value of the radicand. So in this case, the absolute value of x. And the absolute value of x, you know, is just x. At this point, you compare your indexes and your radicands to see if they can be subtracted. So you have your indexes are the same, but your radicands are different. So you can't go any further. So your answer is 3 square roots of x minus x square roots of 3. Okay, number 55 says the cube root of a, and it's not a squared, so just ignore that. The cube root of a minus 4 times the cube root of a plus 5. Okay, and ignore this right here. I just got screwed over a little bit. All right, so now we're doing a binomial times a binomial. So this one's a little bit different. We're going to take the first term of the first binomial and multiply it times both pieces of the second. And then we're going to take the second term of the first binomial and multiply it times both pieces of the second. Some of you might know this as FOIL, but I call it double distributing. All right, here we go. We're going to take the cube root of a and multiply it times the cube root of a, and then the cube root of a and multiply it times 5. So first, it's the cube root of a times the cube root of a. They have the same index, so we're multiplying, so all we need is the same index. So it ends up being the cube root of, and then you take your radicans and you multiply them together, so a times a is just a squared. And then you're going to take the cube root of a and multiply it times 5, which is going to give you 5 cube roots of a. And it's positive 5, which is where I got this plus from. That's just like if this were x and you were multiplying it times 5, it would be 5x. It's just 5 cube roots of a. Minus, it's going to be negative 4 times the cube root of a. So negative 4 cube roots of a. And then it's going to be negative 4 times positive 5, which is negative 20. Now you're going to look to see if there's anything we can simplify or anything that's that we can combine. These are both cube roots of a, so I can combine them. So I can say 5 cube roots of a minus 4 cube roots of a is just 1 cube root of a. So this is going to be 1 cube root of a plus cube root of a squared minus 20. Now remember, we don't have to write this 1 here, and you should always put your exponents in order. So the answer in the book would probably say the cube root of a squared plus the cube root of a minus 20. And you can't combine any of these because even though your indexes are the same, your radicans are not. So you can't go any further. So that is your answer. All right, here we're going to do the same thing we did earlier. We're going to distribute the square root of 2. So the square root of 2 times the square root of 2, you can multiply those together because they have the same index. And then you just multiply the radicans together, so 2 times 2 is 4. Plus, we're going to take the square root of 2 and multiply it times x square roots of 6. So because our indexes are the same, here and here, it's going to become x square roots of 2 times 6, which is 12. Now, we're never done until we simplify it as far as we can. Square root of 4 is 2. We know that. Plus x, let's see if we can break 12 down any. We've got 4 times 3 and then 2 times 2. In order to pull a number out front, it would need to repeat 2 times because my index is 2. So I've got 1, 2. That means I can pull a 2 out here. And then I've got a 3 left over. And so it becomes the square root of 3. You should write these in order to make it prettier. So it'd be 2 plus 2x square root of 3. And that is your final answer on that one. All right, next we have another set of binomials being multiplied together. This is the square root of x minus y times the square root of x plus y. So this is plus, ignore this over here. All right. Again, when you are multiplying binomials together, you'll take the first term of your first binomial, and multiply it by both terms of your second. And then the second term of your first binomial, you'll multiply them by both terms of your second. So first, we're going to take the square root of x, multiply it times the square root of x, and then the square root of x times y. Square root of x times the square root of x, they have the same index, so we can multiply them together. You just multiply the radicans, which give you x squared. X times x is x squared. And then you're going to take the square root of x and multiply it times y, which is going to give you y. Square roots of x is a positive y, that's why it's a plus. Then you take your second term and multiply it by both terms of the second binomial. So it's negative y times the square root of x. So negative y square roots of x. And then you take your negative y and you multiply it times your positive y, and you get negative y squared. Remember, a square root and a square cancel them out till you get the absolute. Okay, this is actually a minus right here. And try to ignore this in here. Sometimes it doesn't convert very well from PowerPoint to this. Okay, so here we go. We have two binomials being multiplied together. So we are going to take first term of the first binomial times both terms of the second binomial, and then second term of the first binomial multiplied by both pieces of the second binomial. So first things first, square root of 5x multiplied by both the square root of 5x and then negative 3 square roots of 3x. So first it's the square root of 5x times the square root of 5x. And we know we can multiply those together because they have the same root, same index. And then you just multiply the radicands together. So 5 times 5 is 25. And then x times x is x squared. And we know that that's going to simplify to 5x later, but we'll just go ahead and leave it as it is for right now. We'll simplify in the next step. Then we're going to take the square root of 5x and multiply it times negative 3 square root of 3x. Now, it gets a little bit tricky when you're multiplying radicals with coefficients out in front, but the way I like to do it is I just look at it as just multiply the coefficients together. So the coefficient here is 1, right? We have 1 out in front of here. And then the coefficient here is negative 3. So 1 times negative 3 is negative 3. Then take your radicands and multiply them together. And make sure that you keep your index the same. So you know it's going to be the square root. And then 5x times 3x is 15x squared. Because 5 times 3 is 15, and x times x is x squared. We're going to do the same thing when we multiply our second term times both pieces. So second term times first term, your coefficients are negative 2 times 1. So that's just negative 2. And then your radicands are 3x and 5x, which again is 15x squared. And then you're going to multiply negative 2 square root of 3x times negative 3 square root of 3x. So here our coefficients are negative 2 and negative 3. Negative 2 times negative 3 is positive 6. And then your radicands are 3x and 3x, which is 9x squared. Okay, so we're done multiplying. Now we're going to add or subtract. But first we need to simplify some stuff and see if we can clean this up. So we know that the square root of 25 is 5, and we know that the square root of x squared is just x. So that becomes 5x. Square root of 25x squared is 5x. Here you have the same indexes and radicands, so you can actually subtract or add their coefficients. So negative 3 minus 2 is negative 5 square root of 15x squared, which we're also going to be able to clean up a little bit later, plus 6. You know the square root of 9 is 3, so this would be times 3. And you know the square root of x squared is just x, so it's actually times 3x. So let's clean up what we can even further. So we have 5x minus 5. Now, the square root of 15, we can't do anything with that. But the square root of x squared, a square root and a squared cancel each other, right? So you can actually just bring an x out front here. And then you leave the square root of 15 inside. So all we did was bring this x out front because a square root and a square cancel each other. And notice here, the 15 is not being squared, just the x is being squared. And then we also know that 6 times 3x is 18x. So we're going to say plus 18x. And then we can go even further because 5x and 18x are like terms, so 5 plus 18 is 23x minus 5x times the square root of 15. That is our final answer because we cannot go any further. And then your last one here is a binomial times a trinomial. Okay, that's no problem. We've just added a little bit more distributing in. So we're going to take our first term, multiply it by all three of the second term, of the trinomial, and then our second term and multiply it by all three of the trinomial. And then we're going to combine and all that crazy shenanigans. So first thing, cube root of x times first term times second term times third term. So we start cube root of x times the cube root of x squared. Our indexes are the same, so that means that we can multiply these together. So it's going to be the cube root of our radicans being multiplied together, so x times x squared, which is x cubed. Again, we know we're going to simplify that later on, but just leave it for now. Then we're going to do cube root of x times negative cube root of x. Our indexes are the same, so we can multiply, and it's going to become negative because of our negative here. So negative cube root of our radicans, which are x times x, which is going to be x squared. And then we're going to take our cube root of x and now multiply it times 1. Anything's times 1 is just itself. So this is just the cube root of x. Now we're going to take our second term and multiply it by all three of the trinomial. So first we have 1 times the cube root of x squared, which we know is just the cube root of x squared. And then we're going to take 1 times negative cube root of x, which is just going to give us negative cube root of x. And then we're going to take 1 times 1, which is just going to give us 1. All right, got a lot going on here. Let's see if there's anything we can combine. I've got cube root, cube root, cube root, cube root. Do I have any radicans that are the same? X cubed? No, 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 no. X squared? X squared. So these two can be combined. X, X. So these two can be combined, but nothing matches up with this. However, don't we know a cube root and a cube cancel each other out to give you the absolute value of x, which is just x. And then if you have negative cube root of x squared and positive cube root of x squared, don't those just cancel each other out? And then if you have positive cube root of x and negative cube root of x, don't those just cancel each other out? And then you've got this plus 1 at the end. Can you go any further than that? Nope. So that is your answer. And that is it. Have a great day.